My name is Jose Luis Lopez, and I'm going to present the following poster: Green Synthesis and Characterization of Metallic Nanoparticles with Environmental Applications. In this work, the green synthesis of silver and gold nanoparticles was carried out using sargassum extracts. As many of us know, for several years, the massive arrival of this algae has been seen on the coast of the Mexican Caribbean. Therefore, the possible uses and applications have been investigated. In this sense, the antioxidant capacity has been determined, so it can be used as a reducing agent in the synthesis of nanomaterials. The methodology used in this work consists of 5 stages. The first consists of washing the sargassum to remove impurities. Then an extract is prepared by infusion, for which 1 gram of dry sargassum and 50 milliliters of a 50 water ethanol solution are used. The mixture is heated at 60 degrees Celsius and is kept under magnetic stirring for 30 minutes. It is allowed to cool at room temperature and is filtered. The synthesis of the nanoparticles is carried out by mixing a precursor salt solution with the sargassum extract and sodium hydroxide to adjust the pH. The salts used were silver nitrite or chloroauric acid for the silver and gold nanoparticles respectively. The obtained nanoparticles were characterized by UV spectroscopy, FTIR, X-ray diffraction, and scanning electron microscopy. Finally, the catalytic properties of the nanoparticles were evaluated through the degradation of organic dyes, such as methylene blue, methyl orange, and methyl red. As a result, the type of solvent used in the extract was first evaluated, that is, ethanol, water, and a 50% ethanol water mixture. As can be seen in the UVB figure, the water ethanol based extract showed the best results, since a more intense absorption band is observed, indicating the presence of higher concentration of nanoparticles. The result is observed for both silver and gold nanoparticles. On the other hand, the volumetric ratio between precursor salt and sargassum extract was evaluated. In this case, it's observed that as the extract increased, the absorption band corresponding to the nanoparticles increased too, indicating a higher concentration of nanoparticles, which is attributed to the greater presence of reducing agents from the extracts. It's important to note that the position of the band has no significant changes, indicating that the size and size distribution of the nanoparticles is similar in the samples. The samples of the extracts and gold and silver nanoparticles were analyzed by infrared spectroscopy. The results showed changes in the signals of the bonds corresponding to the phenolic compounds, for which the reduction of silver and gold ions is attributed to this type of compounds. On the other hand, the crystalline nature of the samples was corroborated by X-ray diffraction, where the presence of silver and gold was evaluated as unique phases, but with a face-centered cubic structure. Scanning electron microscopy showed that the silver and gold nanoparticles have a nanometric size with a quasi-spherical morphology. Silver nanoparticles are between 20 and 40 nanometers in size, while gold nanoparticles are smaller than 20 nanometers. In the same figures, it can be seen the organic part from the sargassum extract that surrounding and stabilizing the metallic nanoparticles. The dyes used to evaluate the catalytic activity of the silver and gold nanoparticles were methylene blue, methyl orange, and methyl red. As can be seen, the degradation was carried out faster with the gold nanoparticles. For example, methyl orange took 10 minutes to degrade with silver nanoparticles, while gold nanoparticles only took 6 minutes. Moreover, in the in the last figure, it's possible to observe the disappearance of the color in the three dyes, which demonstrates the complete degradation of the blue, orange, and methyl red. With these results, it can be concluded that sargassum has organic compounds that can act as a reducing and stabilizing agents in the synthesis of metallic nanoparticles. On the other hand, silver and gold nanoparticles have the ability to degrade organic dyes, so they can be used in water remediation, being a safe and efficient method.